right, I think we're ready. Nobody's live right now, but so I guess it's working. All right, we're going to talk about this idea of mesh mixing and a way that you can do simple multicolor, two color, or more. I guess you could do more prints with any printer, so you don't have to, or any FDM printer. Nothing special. You don't have to go buy any parts to do that or anything. Let's look at our Bondtech upgrade. I went ahead and finished it up. So there it is. It was actually pretty straightforward. There weren't a lot of unusual things. I used all the existing electronics. So, well, we had changed out the motherboard to the SKR Mini E3 version 2. So it does have that. It would have worked fine with the previous, I think it had the Creality 4.2.2 board. It would have worked fine with that. The extruder doesn't change any of that. You will possibly need to change your E-steps, but other than that, you certainly will have to change your E-steps with this particular extruder because it's very different from what was already on the Creality. I did have to create a little mount here for the BL, or well, that's the CR Touch for the bed probe. I did have to create that. I just went in SolidWorks and drew it up just so I could get it mounted. There is a spot to mount over here somewhere, and so this little bracket came as one of the options in the CR Touch kit. You know, there was like, I think maybe 3 different brackets you could use. That was one of them. That wasn't the one I was originally using. But it does mount there. The problem is that it puts the CR Touch too high, and it was hitting something. I think maybe it was hitting the back here or something. I don't remember what it was hitting. So it was in the way. So I had to bring it forwards a little bit and drop it down, I don't know, 1/2 inch or so. So that's I need to redo a little bit on this bracket. It's got one of the screws in a little bit of a bind, but it's on there pretty good now. It still rattles. But that was fine. All the other parts were parts of the kit. Now this kit was the DDX, so the direct drive extruder, plus some adapter parts to adapt it to the Ender 3. And the way the fan, you know, this fan and this side fan, oh, we can't see those. Let's get down there at them. There they are. Very close though. This fan doesn't have a guard on it for one thing, so I'll probably have to print something to, you know, just keep it from accidentally getting one of the fan blades broken off. And this side fan, the layer cooling fan, those are both from the original printer. This duct and everything is part of the kit. So overall, it went together really straightforward. I couldn't find some obvious instructions on how to put it all together, but found enough that it made sense. The only thing that was maybe a little bit tricky is getting I can't see it back there, but getting that has the copperhead hot end on it and getting it down in there. I had to open up the case here. So this little case, I had to open it up and just to get some clearance to put it in there. I didn't have to take it completely apart, just had to get a little bit of clearance. The way the fan is mounted is a little bit weird. I think it works fine. It's slightly wobbly, but I don't think it's a problem. It is adjustable up and down. Right now it's all the way down because of the length of this hot end is pretty low. I did lose probably, I don't know, 1 centimeter or so of Z height probably, but it works fine. I did say that this nozzle looked larger, and it is larger. It's a 0.6 millimeter nozzle, so we'll have to, I haven't tuned anything other than I tuned the E-steps. I printed a whole bunch. You can see a bunch of these things back here. Printed a whole bunch with it, and it's printing fine. But it could probably print a little bit better. Why don't we, let's see, what do I want to do next? Why don't we calibrate flow? So I haven't done that on this printer, and I haven't done it on any of the other printers. So here's a way that we can do that. So we need to go to Cura. So let's get Cura open. And I've already built went in, added a printer and added another Ender 3, so it has the right geometry for the bed size and all that kind of stuff. I added all that, and I created one profile here with a different layer height. So now that it's got a 0.6 millimeter nozzle, I want a larger layer height, or I can print with a larger layer height. In fact, printing too small now is going to be a little bit of an issue. If I go too far below, I don't know, 0.2 is probably a safe lower, like thin layer. I could probably go a little bit lower than that. But now that the nozzle is much larger than it was before, then it's going to be harder to print thinner layers, but easier to print larger layers. I've been printing at this point 0.35, but I want to go to 0.4. One thing you have to do, so it used to be that you kind of define the nozzle diameter size in the printer profile, but what you do now is if you go to line, search for line, there's line width. That line width is the basically the nozzle size. Now you can print, or you can try to print larger line width than your nozzle, so it kind of squirts out more filament to make it ooze out to the edge. I assume you can also try to print thinner line width. In fact, it even says, if you look in the pop-up there, slightly reducing this value, the line width, could produce better prints. So you can kind of undersize the amount of extrusion coming out. So I've set it right at the nozzle diameter right now. So I haven't tuned with that at all. So I've got it set up to where it assumes it's going to print 0.6 millimeter line width. All right. What's a couple of things that does when you jump to a larger diameter is it does do a little bit on reducing the thin layers that you can print. But now that the nozzle itself is larger, I can print thinner walls. Now I've been printing with one wall just to save some time, because I've been printing a lot of like test pieces, and so I don't care that they're necessarily perfectly finished right now. I just want to get them done quick. So I've been printing one wall, which that one wall now is as thick as 1.5 walls would have been with the 0.4 nozzle. So you can get stronger parts with fewer walls if you have that larger nozzle diameter. Same thing with top and bottom layers. I've been printing thicker layers, so I don't need as many top and bottom layers. I could probably get away with 3 top layers just to get the surface finish a little bit better. But I've been doing 2. I've been doing a lower infill because now it's, I've always kind of done a lower infill, but this one is going to have that larger line width on the infill also. I'm printing a little bit hotter than I had been because I'm trying to extrude more filament, because it's a bigger nozzle. So I bumped it up a little bit. I could probably go through a temperature tower and, fine tune what that number needs to be. I just raised it 5 degrees. I'm printing kind of slow still, 50 millimeters per second. That's not terribly slow, but I could probably go faster. Still got print cooling and all that. I had been using support. Let's turn that off. All right. So to calibrate flow, what flow talks about is once you get your E-steps right, which, that's a little bit different on this one also. So let's see if we can back up. So there's no, here's the extruder, and there's no way to just see the filament coming out of it. So instead, I elected to see the filament going into it. So I went over here, right here, and I marked 120 millimeters on the filament itself. So I wrote an actual mark on the filament. I don't have a pen handy that's going to write on it, but went over here and wrote a little mark for 120 millimeters. Then I told it to extrude 100 millimeters, and so it would send some of this in, and hopefully that mark that I made would end up 20 millimeters from, I was measuring from the end of this Bowden tube, so 20 millimeters from there, I'd be right on 100. And if I wasn't, then I'd go to the online calculator, put in my current E-steps, and then I only extruded 90 millimeters, but I asked for 100, and it would give me a new E-step value. So it did that versus the way I did it with the remote, the Bowden extruder, where you can just see how much filament is coming out of it. So in this case, you have to see how much filament is going into it. One thing about that is when you're measuring the filament going out, there's no resistance at all. So you don't really have to worry too much about how fast you're extruding. But when you're measuring how much is going in, it does have to go through the whole system here. And so there is resistance because it actually has to extrude filament. So you need to extrude slower. So I did a feed rate of like 200 millimeters per minute on it, I believe. So if you try to feed too fast, measuring filament going into the hot end, then it's probably going to give you a miscalculation. So I did have to use G-code to go in and do a G1, and I did a feed rate of 200 and E100 to extrude 100 millimeters of filament. So I had to do it manually. Now, one thing that's good about this SKR in this touchscreen is that I can write G-code on the screen itself. So I don't have to log into Phase or something like that and send G-code. You can actually write G-code on the screen with this one. So that's kind of handy. All right, so we want to do flow rate. So what flow rate is, once we get that right, once we get the E steps correct, now what I want to see is, I know that it's extruding the amount of filament I tell it to extrude. So what I want now is it pulling down, you know, if I have a line width of 0.6 millimeters, is it actually putting down 0.6 millimeters of filament? Is that how wide it actually is? Because there could be some variables that aren't quite lined up. Maybe my nozzle diameter is not 0.6, maybe it's 0.59 or something, I don't know. So what we can do is go to Cura, and again, I've still got my parts for calibration, just add a cube. So we just add a cube, and I want to print this cube in what's called vase mode, or spiralize outer contours. So if we look at, let's see if we search for vase. I don't know if that'll show up in here. Yeah, it's spiralize. So spiralize outer contour. So what that'll do is it'll print one outer line for whatever shape I've got, and it's kind of in a helix. So it's just going to be one wall. So we'll do that. That just speeds it up a little bit, and I don't have to worry with any retractions or anything like that. So let's set that on. Let's go ahead and turn off the top layers. We don't need any top layers for this, so 0. Spiralize probably will count those off anyway, but bottom layers 2 is fine. There's not going to be any infill. It's just going to be a outer wall, so everything else should be okay. All right, let's slice it and then preview it to make sure it's doing what we want. We want like a box with no lid on it, and that's what we have. So we have one wall here that is a spiral pattern, and 2 bottom layers, so it sticks down. So what I'll do is, and it's going to take how long? I'll get out of the way. 8 minutes, so no time at all. So let me get my little SD card. And let's save this. Actually, let's name it something. Oh, wait. There we go. Nope. There we go. Let's save it as flow test. Oh, wait, that was open. That's open. Never mind. Let's save. But it saved it over here as untitled, so I don't want that. Let's rename that. Okay, now let's eject that little file or the SD card, and let's go over here and print it. So it's going to take a little bit of time because the printer's not heated up or anything, so it'll take a little while for it to do that. We'll get it started, and then we'll move on to something else. Okay. It also does do the 9-point bed probe before every print. I put that in the start G-code, and we can look at that. I don't think I actually ever said, maybe I said that? I don't remember. But if you want to do the little mesh level, if you have the BL Touch or CR Touch, and you want to do the mesh bed level before every print, you can add it to your start G-code. So right here, it's just this one line G29. If you have a really dense mesh, like 5x5 or something, it's going to take a while to do. Maybe you do that one and store the mesh, and you can use a code to just remember that stored mesh. This one, G29, we'll go in and just probe. I'm only doing 9 points, so it doesn't take very long. But it will take some amount of time. Whenever it clicks on to do that, I'll put the camera back on yet. So our idea here is that we're going to print this little box, and then we're going to measure each of these walls and see if they're 0.6 millimeters. If they're larger, then we need to dial back the flow. So the flow rate, let's see what we have for flow settings. So I've got this, I just typed in flow over here. And so I've got wall, outer wall, inner wall. Now, right now I only have outer walls on this print, but I can tune back or up, either one, by a percentage, any of the different flow rates. Maybe I want more flow on inner walls for some reason, or I can just take the percentage for all of them. I can do that. I can change, and I can change it on the printer too. There's a tuning setting as the printer is printing to change flow rate. So we can change it. So I'm going to go and get our calipers. Where did I put them? Oh, they're over here. And we will measure each of these walls. We'll probably measure each of them twice just to have some kind of average. And then we will see what our wall thickness is. Now this one is one where sometimes you have to override the theoretical calculate. Like I might calculate this and get the flow exactly 0.6 millimeters, but it just doesn't look right. So there are times where you might have to override this, you know, bump it up or down a little bit just because it doesn't quite look right when you're printing parts. But our E-steps should be correct. Oh, here it goes. Already heated up. This is one thing. It does heat up faster with this Slice Engineering hot end on it. So we'll look at what it's going to do. So it's doing the probe. I have not changed the probe offset. So making this new probe, put the probe mount, put the BO Touch in a different relation to the nozzle. So I need to go in. I have to do that in the firmware. That was it telling me it hit the end stop, so it's fine. It's going to probe the 9 points, so you can kind of see how long it adds to your print when it does this before every print. And if you did one of the larger meshes, it starts adding up to a lot of time. But I think the 3x3 mesh is fine for a bed this size. I probably don't need any mesh, honestly. But since I have the touch probe on there, might as well use it. And we're still using the, I think that was the energetic bed, textured PEI sheet. I think that's who it was from. I don't remember the name brand on it now, and it's not written on that side of it. But I think that's what it was. So far, this one has been doing really well about detecting the bed, and I don't need to go and adjust it. I do have, well, you can't see it, but on the screen over here, I do have baby stepping where I can adjust live, like as it's printing. I can adjust the Z height, but I haven't been having to do that. So we'll see how it does this time. I wonder if we can get some other view. I took that other camera somewhere else. I don't know where it went. So there you can kind of see it laying down the purge line. That looks fine. It started out a little sparse, but now it's fine. Look, that looks fine. And I do still have it printing skirts, 3 skirts right here. I like that because it does a couple of things. It lets me see where the print's going to land, make sure it's in a good spot. And it gives me a little bit more time if I want to adjust the Z height. You know, you can do it manually. You can actually turn these knobs as it's printing. If you see that you don't have baby stepping on, you can adjust it manually. You might want to add a few more skirts to give you more time to get it right. But looks like it's going to print fine. We'll let it go. It's not, like I said, it takes 8 minutes to do this one, so it won't take that long. But as it's going, we'll we'll go ahead to do our next thing. So the next things I wanted to do, there's 2 things. If we get to them, one of them we will get to because that's what we're going to do next is MeshMixer. I have that pulled up over here. So meshmixer.com. Autodesk has bought this. I don't know who originally created it, or maybe Autodesk did, but I think Autodesk owns it now. They give you this big note. And this note's a year old, that they're not going to support and develop MeshMixer any more than what it is right now. So it's an older piece of software. Their note is telling you that Fusion 360, that's Autodesk version of something like SolidWorks. It does a lot of the things that MeshMixer does. And it probably does. I just don't know how to go into Fusion 360 and use it as well as MeshMixer. So someday someday they'll probably, some update will break MeshMixer where it just doesn't work anymore or something. I don't know. It does work. It does have a potential to crash though if you're working with really large files. So you do save often. If you use MeshMixer, you get in the habit of saving relatively often. But so they tell you this, that they really want you to use Fusion 360, which is free for students. It's free for anyone. There are some limitations. But if you have a .edu email, then you can get the whole thing for free. Actually, you can get a lot of Autodesk products for free with a school email. So somewhere on here, there's going to be a download. Click here to download. All right, I've already done that a long time ago. They've got a user manual. I don't remember what's in the user manual. I don't remember looking at it before. Yeah, it's got a little bit of tools over here to kind of get you started with it. But it's this piece of software right here. All right. So the idea is that MeshMixer does a couple of things that that's its thing to do. The name MeshMixer it was kind of created to take meshes, so STL files. It doesn't have to be just STL files. It can be OBJ, PLY, STL, AMF, 3MF, OFF, and mix. Well, mix is MeshMixer file format. So it can take these generic geometry files that you might get from Thingiverse, or maybe you made it, or whatever. You got this file, and you can mix them together. So you can take parts of one and stick them onto parts of another. So it's for maybe you're not that great at creating brand new models, particularly organic type things. You can use MeshMixer to mix together stuff other people have made. So it's good at that. It has a little bit of this over here, sculpting. So there's better pieces of software that are made to do sculpting. Autodesk is called Mudbox. The other one is called ZBrush. So there's some that are made to do this, but MeshMixer will do some of it. And what it is it turns your geometry basically into like digital clay, and you have these tools where you can sculpt on it. So you can add creases or smooth something out or whatever. So it can do that. And it does have a little bit of direct editing and analysis. So like it can fix holes in models and things like that. What I'm going to do with it is kind of the name, MeshMixer. We're going to take some meshes that we find off of Thingiverse and put them together the way we want them. So let's go to Thingiverse. And again, we're going to take a really straightforward approach to this, assuming Thingiverse will cooperate with us. There we go. And you can do a lot of cool things. Like you can take big models and slice them into smaller pieces, put little registration keys so that when you put them back together, they fit together the way they're supposed to be. You can do all kind of things like that. We're going to take the very simplest thing right now. If there's interest in it, then we'll add some more of the higher order type things that you might want to do with MeshMixer. I'm just going to find some little, let's look at a Hero Quest model. So let's find something here that we want to create some guy. Let's take this guy. I think I used him last time. So Hero Quest is a game from the 90s, late 80s, early 90s. They just re-released it, but these are little models that are in there. So this is a scan. We'll talk about scanning later. There's a couple of different ways that you can scan geometry. Whoever did this scan has a pretty high-end scanner, it looks like. But you can scan, maybe scan is the wrong word, but you can create geometry with your phone or a camera. It's not as nice as what this is, but because these things are like an 1.5 inches tall. But we'll look at how to do some scanning. Let's download this guy. Let's say that we don't like the base he's on because it's kind of boring. So let's find him some kind of, I don't know what to search for. Nope, none of that. There's a fancy one. I want something pretty straightforward. Actually, these crystals might be kind of fun. We can embed him in there. Let's download that. But we want something else. Maybe if I put miniature. I spelled it wrong. Thingiverse is not particular. Oh, there were some though. Not particularly good about figuring out what you meant to spell if you spell something wrong. Our little cube's almost done. Also, so we'll have to flip back over to that simple base. Oh, here we go. These look perfect. All right, so there was one even that kind of looks like he's walking on some stones. Let's grab that one. That must be that one. All right, so we've got him. Oh, he was just holding. He wasn't holding anything. Let's get him a sword. Again, Thingiverse, sometimes you have to reload often. Because it gets sluggish. Or, oh, we could do the Minecraft sword. Do a baby looking sword. I want something pretty simple though. Because it's going to be kind of small. Or it's going to be very small actually. Give him the Master Sword. Thundar. I want one that's very basic. Because all these little tiny pieces are probably not going to survive at the scale that we're printing at. Oh, here we go. We can give him He-Man sword. He kind of looks like Skeletor, so. Oh, wow. This one is this is like for full size. I just want the solid. I don't know if they have it built all together. That looks like that's all in pieces. But now we can look up. I just want one that's a solid one, not a multi-piece one. And again, what's its name? Thingiverse is not particularly great at figuring out what you wanted. There's a Lego sword. That one looks pretty simple. Oh, here's one. It's kind of dull, but that looks like it might work. We'll download that one. All right, so we got our models, and you could keep going. You could spend a bunch of time going through this. Before we get to that, let's go over to our printer. All right, so here's our little part, and we've got our calipers out. Now, make sure you zero out your, yeah, we're pretty close to zero. There we go. And these are supposed to be 0.6 millimeter thick walls. So don't measure right at the corners because the corners have a little bit of a fillet inside there, just the way it's printed, and they will be thicker. So measure, you know, somewhere, maybe 2 places, somewhere over here. So that actually says 0.9. 0.9. 0.8. 8. I'm going to have to peel it off of there. 8.5, 8, 8, 6.8. So what that's saying is that we're way over extruding. So if we are actually doing our E-steps correctly, which I thought we were, you know, I kind of did check those, then there's still something in there that is way over extruding. We wanted a 0.6 millimeter wall, and we're getting, you know, 0.8. I don't know if I average those together, it was something like, I don't know, let's just say 0.85. So we're definitely over extruding. Now, what we would do is get this off of here. Get our little calculator. Well, let's just go to Google. So we have, let's see, we want to do, we're over extruding by 0.25, right? So we're like 40% over extruding. I don't think I want to drop the flow rate down quite so far, like down to 60%. That seems extreme. I might need to check. First, let's check our filament diameter, make sure it's actually 1.75. Maybe I have really large filament here. No, the filament diameter looks right. I should probably measure it in a bunch of places, but the one place I randomly picked was right around 1.75. So that's probably not it. We might have our E-steps off some still. So we might want to check those because it seems like it's over extruding a lot. Yeah, I mean, it's just way thicker than it should be. So what I would do is I would actually probably go recheck my E-steps again because that seems a bit much, but not there. There. I could go back to this flow rate and I could drop it down to 60%. Seems like a lot though, so I don't know if I'd go all the way to 60, maybe 80%, but normally when I'm changing flow rate, I'm going down to like 95% or up to 105. You know, that little bit of variation there I could see. This one kind of makes me think that our E-steps are still wrong. Although it's been printing fine, but you know, I look at these parts that it's been printing, and now I'm printing them really fast. So where we go? So they definitely are going to have issues. Like the Z seam is pretty pronounced. You can see the infill, but I only printed one wall. So I was thinking that the issues with these prints were because of the way I was printing, like one wall, pretty fast, kind of hot. All of those things would make it over extrude. The support, I was using support on a couple of places and it was really sticking to the model in some places. So I was thinking that was just the way I set up the print was the issue there, but maybe it is over extruding a lot. So I probably could drop this flow rate down a little bit. I don't want to go down to 60% though. So I'll probably come back off screen sometime and check the E-steps again, make sure that they actually are right. They could still be off a little bit, and drop the flow rate down some. So it seems like we're definitely over extruding. Now our parts, you know, they're fine. They work. They could probably certainly be better, but they're actually not bad at all. You know, you can kind of see where the supports were getting stuck inside there. In fact, this one, I think I had to cut the supports out. That's why it's so jaggedy. But the part looks fine. So that's flow rate. And again, it's one of those where, yeah, I measured that it's way over extruding, but the parts are looking okay. So I might drop the flow rate a little bit. I might check the E-steps. And, you know, it kind of gives you this clue about your printer slicer. The software is not directly talking to your printer, so it's having to make assumptions about what's going to happen. You know, how much filament's going to come out and where it's going to land and when it's going to cool, that kind of stuff. And then your printer just does it without knowing what actually happened. So you do usually want to check flow rate to make sure that you're in the ballpark. Right now, it doesn't kind of look like we're in the ballpark, although our prints look okay. All right, so we'll come back to that. I'll go in and re-measure the E-steps and then do another flow rate test and see where we're at. And probably looks like I'm going to have to drop the flow rate a little bit. All right, so let's get MeshMixer. All right, so our idea here is we got all these parts. We got 4 parts. We got the guy, a base, a sword, and a little piece of crystal stuff. So let's grab the guy first. Oh, did he not download? Uh-oh. I thought I downloaded him. Oh, it failed. Here we go. Let's resume. There he goes. All right. So there he is. So let's open him. So I just clicked on import. So there he is. He's probably gigantic in this scale. So we'll have to scale him once we do the slicing. You know, once we get him into Cura, then it'll give us an actual height that I can trust. Here, who knows what scale he's at, so I don't know. But let's get him in there. Let's import, and now when I want to add a new model, I can append, mean add to the one I already have. I can replace, which means get rid of the little guy here, and bring in the new model, or I can just cancel the idea. I'm going to append, and we're going to append the base, because we don't like the little plain square one. All right, so it actually looks, you know, pretty close to the right size. We might want it a little bigger. So now over here in the object browser, you can see I've got two different things. I can select them. One thing that's usually good to start out with is this analysis and the inspector, because it'll go and find holes that might be in your model. Didn't seem like there were any in that one, so that's good. Let's check the other guy. Doesn't seem to be any problem there. All right, so let's go to edit this little base, and there's transform, so I can get this little gizmo here that's got all sorts of, you know, I can move it, I can scale it in certain directions. I can make it an oval base. Control Z undoes. The middle one can scale in every direction. I don't know if there's a simple way. Can I type them? I can type in over here. So maybe I want to scale in, let's see, Z is, which way is, all right, that's Y, green is Y, all right. So X and Z, so maybe I want to scale X and Z without making it too much thicker. So X and Z, maybe 1.5. That might be a little bit big. Let's do 1.25. That looks good, and let's kind of position it. So we're just kind of looking to see where his feet, something like that. Now you can kind of see the old one. Well, let's accept that. You can kind of see the old one sticking through there a little bit. One thing I can do is I can go to this old one, and that's where the sculpting stuff comes in. So I have various brushes here. Some of them move stuff around, some of them flatten, some of them add spikes. You know, there's a lot that to just play around with. I'm going to use the one that moves. So this move one. And I'm going to, this size here can be controlled with these sliders. So strength is how much does it move when you move your mouse and click on it. Size is the size of the sphere here. You know, how much are you affecting at one time, but I kind of want to like pull this stuff down out of the way. I don't want to mess this. Let's see. I can just kind of, any of that other mesh that's sticking through, I can just kind of pull it down into the base. Now it might be, yeah. No, I'm not dragging it through the bottom. That's fine. I'm just kind of, you know, I don't want those filled in. So you can, before you glue them all together, whoops, you can kind of do this stuff. And he's going to print better if this is embedded into the base versus just kind of hanging in midair and I have to support it. So that's kind of what I want to do there. Let's see if we can make this a little smaller and kind of get these maybe a little bigger than that. There we go. And you can do that all day. You know, you can edit all this you want to. He's got this little seam line from where he was actually a piece of plastic at one point. Got to remember how to move around in here. All right, there it's middle mouse and drag. So I've got a smooth brush. Actually, there it is right there. Shrink and smooth. Actually, I think if you hold down Shift, no. So you can just click on there and kind of smooth out that seam line. Let's make it a little less strong and smaller. So you can kind of clean it up. You know, maybe there's another one somewhere. There's one there. So you, again, you can do that all day long and make your scan model or whatever it is. It doesn't have to be a scan model. And clean up all this stuff. Now, are these going to show up in your print? If you're doing FDM print, yeah, I don't know, probably not. If you're doing a resin print, which we'll get to later, then yeah, it probably will show up because they have pretty high detail. So that one's kind of ugly in there. We can clean that up. So again, you could spend a bunch of time doing that. You know, maybe you don't like this. So when they originally made this ball here is not really part of the design. It was there so that these things didn't break off. You know, it kind of held them together because it's just a little tiny piece of plastic. Plus, it didn't have pointy ends on the end. So there's all kinds of stuff we could do in there. But maybe you don't want that ball in there. You could cut it out of there. You know, you could smooth it away, chop it off, all kinds of different sculpting things you could do. You could change the way it's created. Maybe his teeth aren't sharp enough. We could go in here and there's a crease. Let's see, pinch is what they call it. And we'll probably go to be really small for that. You could go in there and it's going to be really small. And you could sharpen up. Not doing too much. Maybe pinch is not our best friend with that one. Oh, it's doing the opposite. It pinches. It actually, it's not the crease. I want the opposite of it. I don't remember how you do the opposite on here. Like I want to do a crease. Just kind of like that. Secondary brush, shrink smooth. No, this one, bubble smooth. Oh, okay, that's weird. Yeah, all right. Well, I don't want to fiddle around with that because it's not going to show up anyway. All right, so I've got these two guys. I can go over here and select both of them. So I just held down Shift and selected both of them. And we can Boolean union them. So add them together. Now, these little blue lines are saying that I've got some errors. Maybe there's a hole in the model or something where I did that moving down there. I think it'll be fine. We have to accept this. It looks fine, so we'll accept it. Oh, except it didn't like that error. All right, well, let's try. We may have to go through our, let's see. Let's do max quality. See if that helps it out. It still has these errors right here. Let's see if we can get it to not have those errors. This is one of the things, like they're saying, you know, they're not, oh, there it goes, it didn't. All right, let's see if it, well, it's still thinking. You know, they're not developing it anymore, so there are going to be some issues where, you know, it has trouble doing some things you might think it should do. But in general, it can do a lot of powerful things. Oh, wow. Now I've got more errors. I wonder, let's just give it a try and see. Yeah, it doesn't like that. Let's go back to our analysis and inspector. Let's make it seems like it's all right, but it's definitely giving us a problem. I wonder if there's a hollow spot somewhere. I'm just going through and making them solid to make sure. So I clicked on the model, edit, make solid. Oh, all right. So we definitely need, let's do sharp edge, or let's do accurate, because he got kind of bubbly there. No, let's do no colors. Let's see if that's better. Let me turn the printer off so the fan will stop running. If this doesn't work, we'll go on to some of the other stuff that we can do with the sculpting type things. Because we got to give him that sword for one thing. I mean, he's still definitely... So what I want to do here is I want to make him solid to make sure that that's not our issue when they're merging. But it looks like I'm going to have to keep like increasing the mesh density, 0 offset, so it's kind of wrapping around to the original model. But it's taken a while to do that. I don't want to spend all the time just watching this little bar go around the screen without doing the other stuff. It looks like we won't do the multicolor print today. Just, I don't think we'll have time. Well, I don't know. We'll see. But there is one other thing I want to show you here. I wanted to show you how to join the models, which are being a pain right now. Because ultimately you would want to have them stuck together. That looks okay. We'll accept that. All right, now let's see if our two, all right, these are original ones. These are our solid ones. Let's see if we can actually get those to union. We might just combine them, you know. I didn't think about that. The union might be too much for it. Let's see. Yeah, let's just try to combine them. I probably could have done that to begin with. Yeah, so just combine them. Don't worry with the union. Yeah, now let's make sure he's all one piece. I think he is. Every time I click on him, let's just move him. Yeah, the whole thing moves. All right, so just combine. Don't worry with the union. All right, so we want him to hold this sword. So let's import append. Oh, notice import current MeshMixer document is unsaved. That is generally a bad thing. Let's save. We'll just save him on the desktop as test 1. All right. Because once we start adding more and more geometry here, it does get iffy, like MeshMixer will crash. Let's get that sword in there. All right, so it's gigantic, so we definitely have to scale it down, don't we? Edit, transform, let's get it much smaller. Nope, not that small. Then let's kind of position it over here where his hand is. So this is, I'm just moving in, kind of trying to figure out. It's best to use the coordinate directions first and then the, you know, try to angle it. Because once you angle it, then it's harder for me to figure out how to move it correctly. You know, it looks a little bit fat. Let's scale it in just this direction a little bit. All right. Does that look too big? Let's shrink it down and then let's stretch it this way. All right. Now we've got to make it fit his hand. So let's rotate it, move there, a little more rotate. That's looking decent, but I want it to be turned that way. We're going to ignore the fact that it's got this little guard on it. That was part of the original toy, so we don't need that. All right. Looks like he's kind of holding it behind him the way he's doing that. Let's see if we can pull it around a little bit. All right. And then put it in his hand. All right, now that's kind of cool, but it would be a whole lot better if you actually grabbed a hold of it, right? So let's accept that. Let's go back to here. And this one, if we go to edit, we can do, I think it's going to be in, well, actually, let's select first. And let's select with a larger brush, like his fingers here. Well, I didn't want to do that. I want to get just the fingers. I'm having issues. All right, that looks okay. And then we have edit, where I can do some different, like delete that kind of stuff, cut it off, whatever. Convert to, so I can convert it to just that selection part. But I also have deform and modify. So deform lets me soft transform or transform. I'm going to do soft transform. And just these pieces can be moved around now. And the soft part kind of does a little bit of, like, it's not a hard edge here. It kind of rolls off a little bit. But see, I can start to, all right, he's getting closer. That looks decent, accept that. And then let's go in and select just the top parts here. And do another deform, soft transform. And, you know, kind of do something like this. Maybe we need to do that a little bit. And again, you could spend a whole bunch of time tweaking these little things. We'll do one more just to get that. Oops. Well, that might, I don't want to undo that right now. Oh no, I do need to, because that's not gonna do what we want. And let's see which direction. It shows some weird. You know, all right, so that's not looking horrible. But you could imagine how you could go in there and really get things to work the way you want them to. All right, so we'll just say that's good. And then you tweak on that, maybe move his thumb over and all that as much as you want to. And now I can take both of these guys over here in my object browser, combine them. Again, you probably have some bad printing in here, you know, because I didn't fill these gaps in, so it really does need to have that kind of mesh together. But you could go in and do your sculpting, and you could sculpt now as this is one piece. So you could, I don't know, you could draw inside there with a smaller brush and kind of connect them together if you wanted to. I don't want to do that. That's kind of, I think I would do it more with the moving around with the soft deform. You know, we had the other thing in there, crystal pinned, the little, here they are. That's way too big. So we'll make it much smaller. And you could plop this guy right in there somewhere. Something like that. And combine that. And you start getting like something that, hey, that's pretty cool. Now, is it going to be hard to print? It probably is going to need, you know, some support, or you go in there and reposition his entire setup to where you've got 45-degree angles. It's actually like some of these, like that's not going to print, that's not going to print without support. Not going to print the bottom of this thing without support. Some of this sword is definitely not going to support. It's not the best one for FDM printing, but you could start to see how you could get some unique things that you didn't have before as options, because maybe you couldn't model this, or maybe nobody already had modeled it, but you can get all the little pieces, reshape them, put them together, glue them together, and there's a export, export right here, and you can export as a STL. A lot of other file formats too, but STL, so that you could go in and print the things. Now there are STL, ASCII, and binary. Those both work the same. They're just, are they encoded with numbers, or are they encoded with characters like letters? I usually use the binary format. All right. So that gets you some ideas. There's a lot more that you can do in MeshMixer. A lot of different things that you can do. But I thought I would throw it out there because it's not like SolidWorks or Fusion 360. It's not like any of those modelers. It's really meant not to do stuff from scratch, but to create detail, or to edit a model, or to mash some models together, or to slice a model into two pieces. You know, we didn't even talk about that. If I get some comments or Discord or whatever that you want to know more about how you do this kind of stuff, then we'll do some more. But the other thing that you would want to know how to do in here is maybe you want to print a really large version, but it doesn't fit on your printer. So you've got to slice them into little pieces. There's some good ways to do that with MeshMixer, where you can maybe cut these arms off and then put little pegs inside here so that they actually fit back together. Some registration keys. There's some pretty easy ways to do that in here. I might have made a video about that in the past, I'm not sure. But one thing with MeshMixer, make sure you save a lot, because eventually if you use it enough, it is going to crash on you. It'll just lock up or completely shut down. So you don't want to lose all your work. All right, I think we will have time to do a simple 2-color print. Now I don't, maybe we can actually do the print, I don't know. But here's the idea. So I'm over in Tinkercad now. So Tinkercad is the piece of software I like whenever I just want to throw something really simple together, but it's geometry based. So it's spheres and squares and triangles and stuff like that. Tinkercad is more like organic stuff. So let's just create a new one. Let's say I want to make some tokens for something. Or a coaster. In fact, there is a coaster challenge. I saw, I think it's on printables. So it might be ending really soon, like in the next couple of hours even, or if it's not already ended. But anyway, let's say I want to make a coaster or a token. So I just drop a cylinder in here, click on these corners to get the size. Let's say it's a token. I don't want to do a big print. So 20 millimeters. Yeah, that's fine. Let's make it thinner though. So this height is important because it's going to be the layers. And I'm going to do 2 colors by changing out the filament when I get to a certain layer. So I want even numbers. I'm planning to print at 0.4 millimeter layers, let's say, because I'm using this printer over here with the larger nozzle. And that's just the layer height that I want to print at, 0.4 millimeters. You're probably printing at 0.2 millimeters if you haven't changed anything. So I want this height to be some increment of my layer height, so 0.4 for me. So let's make it, I don't know, let's make 3 layers. So 1.2 millimeters, that might be too thin. Is that gonna be too thin? That's too thin. Let's make it 2. That looks better. Actually, that still looks too thin. Let's do 2.4. Now notice it's faceted here. You can use this slider to make it more round or more faceted. Maybe you want it faceted because it's like a coin or something. Or maybe you might make it more round. So you can do either one of those. I'm going to make it, let's make it more faceted. Okay, so the idea here is that I made this 2 point, I probably should write this down. 2.4 millimeters tall, and that'll tell me if I'm doing 0.4 millimeter layers, how many layers to print of one color. And then let's just make a feature on top of here. Let's make a rim around it. So basically the same thing. Only 2 layers. So let's make it, no, let's do 3. So that's 1.2. Oops. Made a note. Didn't want to do that. There we go. And we need to put this guy on top of this one. Oh, the grid spacing, it's got to drop down because of the thickness I made it. That's something to think about, I guess. There they go. And so this is going to be the rim. So we need to like cut out the middle part. So let's do another one. Click over there. That same one, but let's make it smaller. Let's say the rim needs to be 2 millimeters. You have to think about what's reasonable to print. Actually, the rim, I've got a 0.6 millimeter nozzle, so the rim needs to be either 0.6 millimeters wide, which is really too thin, 1.2 millimeters wide, or so forth. Let's do 1.2, which means I need to make this thing, 2.4, 20 minus 2.4, 17.6. And then we're going to turn it into a hole because I want to punch this part out. If you don't want to try and get these lined up manually, then you can select them and align them over here. And you can align this way and that way so that they're perfectly centered. Now sometimes it moves the part you don't want to move. I think it actually did move the part I wanted right now. Let's raise this up so I don't punch through the whole thing. So there's the surface, and let's go down. I made that. I forgot how thick I made that. We'll go down to there. It'll be fine. And then let's join all this stuff together. So Control A to select everything and group it. And now I've got a little rim in there. And let's say we want some design. There's actually this little symbol over here. It's kind of off the edge of the screen. There we go. This little symbol over here, you can just draw something. I don't know what to draw. Let's just draw some. Oh, a snake. It looks kind of like a snake. So we're going to turn this into some kind of snake thing. It's going to be really tiny, so we don't have to be that super great with our drawing. There is an erase button over here. Get that and that. So there's, and let's put some symbol in here because we don't want to fill it in. So you do all the stuff you want to do with that. Done. And now you've got this guy. Make him 1.2. And we'll just manually scale him and just set him on top. Needs to be a little smaller. So there's our little symbol. Let's align it and the top of this. So that would be this button. We'll align them so that they're at the same height. And then we'll select everything, group it together. Now, there are reasons why you keep these ungrouped. If you have a printer that is able to print 2 different nozzles, or it's got an attachment to it that can print multiple colors and it switches out the colors, then maybe you do want these separate pieces and assign each piece an individual color. We're not doing that way. We're doing much simpler. So here's our little part. We export STL. And I didn't even know, it's surprising to mellow is what it named it. We go to Cura, get rid of our little box. And then we drop in our surprising tumella, which I don't know where it maybe downloads. There it is. And we check our, all right, we're doing 0.4 millimeter layers. Let's do 2 walls so it's kind of heavy. Oh, the dog has found something. Let's do 2 bottom layers, and oh, remember we turned the top layers. Oh, I'm going to intentionally do this, so you'll see, because you'll probably do this at some point. Let's do 2 top layers, and then let's slice it. All right, so everything seems fine. Let's preview it though, and it looks really weird, right? Like the little snake is floating on the surface here. That's because Cura, unless you tell it not to, is holding these settings from last time where we had spiralized outer contour. So that happens to me all the time. I'll have this turned on for print a vase or whatever, or some quick part, and then I go to slice something. I don't want that, but it's still on. So if you get some weird, always preview before you print. If you get some weird thing like this, you've probably left on spiralized outer contours. Let's reslice. That looks more like what I was thinking. It can be that, like right in here, there's some gaps. Those probably won't show up, but maybe the thing you printed, maybe you put some text on there and it just doesn't print. Go over here and you can force, if you do thin, you can force, actually mine's already selected. You can force the slicer, in Cura anyway, to try to print stuff that it thinks is too thin for the nozzle. So I've got it already checked. If I don't check it, I don't know what it'll do. Let's see if it leaves some of these out. No, it does the same thing. But sometimes if you have really thin areas, it will not even try to print them based on how wide the line width is, and that part being smaller than the line width you set. You can do print thin walls and it'll at least try, you know, so that's one way to at least get it to try to print thin stuff. So here, what we would do is, one way you could do this. You could just stop your printer, you know, watch it, sit there. It's not going to take long to print this little part, so you just sit there and watch it. But we're going to do a filament change at that layer 8. When it gets to layer 8, we want to do a filament change. So you could do post-processing, modified G-code, add. There's a filament change right there, layer 8. We'll leave everything else the same here. And then when we slice it, it will have, it will wait, the printer will wait to do a filament change. Basically, it'll retract the filament that it does have in it and prompt you to put new filament in. And then it'll go back to print the last parts. And so you'll end up with a part that has one color on the bottom and a different color on top. Sometimes you have to fiddle around with, all right, is it layer 7 that I want a filament change, or is it layer 8? You know, is it going to do the change after the layer or before the layer? I think it's going to do before the layer, so layer 8 is the one that I want here. 3 minutes. I don't know. I turned the printer off, so I won't have time to get it booted up and actual printing. I wonder if I have any of these. I don't have anything like this already printed. I'll print these or print some of these so that we can look at them next time on how you might can do this. But it's an easy way that anybody can do to, assuming you have 2 colors of filament, to do multicolor parts. So they have to be layered. You know, you can't have your colors all mixed together, but you can print multicolored things like little 2 color coasters, and it can be more than 2. You can have whole stacks of them. There's some really fancy like flat nameplate stuff with, you know, several different colors built into them, where you do several filament changes. So you don't have to have any special equipment or dual nozzles or anything like that. You can do this kind of thing with any printer you have, assuming you have a couple of rolls of filament of different colors. It does work best if the filament is the same type, like all PLA, but even that doesn't have to be true. The thing that could happen though is you could get some little bit of issues trying to get the new filament to come out when the old filament is being replaced. Also be aware Like if this bottom part here is maybe black and the top part is going to be white, there's going to be some length of gray in between there where the colors are mixing together. So you might want to purge a little extra when you put the new filament in if they're drastically different colors. And you can see it coming out of the nozzle before you tell it to print. You can just keep running through more filament until it's the color you actually want. So there will be a little bit of mixing, particularly when you're going from a really dark color to a light color. So if it would be better, if it's possible, to do the light color first and then the dark color, because the mixing won't show up as much. All right, I think we're about out of time. We'll be back on Wednesday, and we'll look at some of these. You know, maybe I'll print out these little snake guys and see what they look like. I'll update on the tuning. So, you know, we were doing our flow rate, and it was apparently way over extruding. So we'll look at that and see if we can get that tuned, and if it makes any difference. You know, this looks like a really nice part. The walls are just thicker than they're supposed to be. All right, I'll see y'all on Wednesday.